Well, hi, and thanks so much for joining me again in my shop here as I continue with this radio. Now, one of you who watches a lot of my videos and comments on almost every one, that would be Mr. David Kerr, who has the wildest ideas I have ever heard before about what to do about all the stuff I work on. David, this one's for you. I've got a new power supply here for the radio I'm going to install. I picked this one because it fits really nice, just like this. David, what do you think? I'm going to bolt it in there, just like that. And this is going to supply power to the radio afterwards. What do you think, Mr. Kerr? Of course I'm not going to do that, for crying out loud. This is the power supply board from my son's television set. And his TV just stopped working entirely. It's a Philips TV. He presented the TV to me, of course. Dad, can you fix this thing? Well, I don't normally fix television sets, but I thought it's completely and utterly dead. How hard can it be? It's got to be a power supply problem. This is the power supply, of course, from his television set. Look, you can see all the diodes in here. Big capacitors galore and that. You know, the surprising thing about this board is it's huge for the number of parts on it. So I guess that's what happens when the TV cabinet is large. You make use of the space, I guess. Or something similar going on in here. What a juxtaposition that is, isn't it? So I have the fuse. I've taken the fuse out. Here it is. Oops, I've tested it. It's open. And that's where I am with this. Open fuse, came right out of here, right by the power cord. And of course right in the manual it says don't go replacing the fuse offhand without first verifying that these diodes are good. So that's the stage I'm at with this board, but I'm not doing this on camera. I'm doing it off camera. And in hopes of getting his TV going again. Okay. And Mr. Kerr, keep up with the crazy ideas. My own philosophy about crazy and practical ideas is that they are always worth exploring because they're the ideas that lead you to the practical ideas, the creative practical ideas. No one else is going to get their head there except those who travel through the crazy territory. Yes, the crazy territory. Okay, so what I'm going to do today is I'm going to go ahead, I'm going to replace this capacitor, and this capacitor, and this capacitor. And that ends all the ends. That means all the capacitors in the audio portion of the radio have been replaced. We will then test the audio side of this radio and see what kind of distortion it produces and stuff like that. I checked the bias on the output tube yesterday. It was just a touch high, which I don't think is a big problem. But if you have a linear portion of the characteristic curve, here it is here between my fingers, you want to try to get the bias right into the middle of it. That way the largest signal possible can be fed into the tube, because it's going to range like this. Whereas if you have the bias way down here, then the signal is going to want to range like this. It's going to go into the curve part of the characteristic curve. You getting all this? My airborne graph here. So that's the problem with it. Is supposedly the bias is supposed to be somewhere around 14 or maybe 15, and it's up at 17. It's a little high. That means if you feed in a big enough input signal here, it's going to hit the upper range. This isn't a cutoff thing. This is a curved deal. But you'll start generating more and more harmonic distortion. So that's what we want to investigate once I get the capacitors changed out. So that is the plan there. Okay, I'm going to go ahead and change those capacitors now. Okay, so the first capacitor I'm going after is this one here. This is a 0.05 microfarad capacitor. So to get there, I don't have a 0.015. So I put together two capacitors here, and that'll add up to 0.015. 0.15. Let's just check them and make sure. Got this right. You see there 15 nanofarads, so that's 0.015 microfarads, right on the money. That's how I'm going to have to do this guy. Why this one is this type capacitor has me a little bit worried, just in case there's something special about it, but I can't imagine what that would be. So it's going away now. Of course, we'll give all these capacitors a test afterwards. Denmark. Why apart from Denmark in the middle of this radio? So this could be a replacement just like these. And then if that's a replacement, I better check and make sure it's supposed to be a 0.015. I will do that. Well, nothing is ever simple, is it? And boy. Okay, so let's take a look at this. What's happened here is the schematic is not matching the wiring in the radio really at all. So it's a little complicated here. This is the area of interest. This is the volume control potentiometer right here. And this is the slider. This is where the audio comes out. 0.04 onto the grid of the audio amp and out to the speaker. Okay. Also on the potentiometer is a backdoor tab. A lot of these volume controls have this connection into the back, or as I call it, into the back, because it kind of looks that way on the actual part. And off of there comes a resistor, and then it makes this connection here, which goes over to this base increment decrement switch here. Basically it's fooling around with this capacitor, and no connection at all. See, when you flip the switch down here, the switch is out of the circuit. These are open circuited. So you got nothing, or this capacitor, or this capacitor. That's what's going on here with this switch. So that being the case, then the sound signal coming out of the detector is fed into the top of the volume control, just as it always is, finding its way to the chassis through the volume control. So you have over here, you have some amount of grounding going on through a capacitor. Well, I don't know what to say. I think the set is, maybe I can find another one of these 0.05s somewhere else. I think it's miswired. I think it's a mistake. I think this capacitor should be connected somewhere else from where it is in the radio. Oh my God, none of this stuff happened to me. Why is it always me? I want to end up with this stuff. Okay. Let's take a closer look. Maybe a closer look will, add more stuff to the confusion here. Let's see. Okay. There's the volume control. Okay, up here on top are the three tabs here. Sorry. 1, 2, 3. Every one of them has a capacitor coming to it. That's kind of weird. There's one there. There's one here. And then the other one was here on this terminal. I wonder where that wire goes. That's on that same terminal there. Yikes, can't really. I doubt I can follow it like this. Huh. What to do? What to do? Well, let's see. I could leave it out. If I could leave it out, it is where it's not supposed to be. I can fix that by not having it where it's not supposed to be, but I can avoid putting it where I think it's supposed to be and see what happens without it, because it's operating without it right now where it's supposed to be. You just leave it out, run the set. So this must be the capacitor conveying the audio signal on into the amplifier. Yeah, no doubt about it. And now for another weird observation here. Okay, so see all these furry, fuzzy wires? Most of the wires are furry and fuzzy. I see this quite regularly. Hey, what's with these wires? These wires aren't fuzzy or furry. So all these wires are the wires that come down from the Magic Eye. Magic Eye is like a unit you install in a radio. It comes with the wires. You shove the wires, into the radio. Here they are coming in, and then you splay them around to wherever they have to go to make the Magic Eye work. No fur. And not only that, see there's fur on all these wires. But look at the wires coming out of the power transformer. No fur. Just an observation. I don't really know what to say about it. I see it all the time. Is it some kind of mildew or mold or something on these wires? I don't know. Okay, that's just a little aside. Why not? I'm all upset about what happened with this situation here, so I need a break. I need a break. Look at that capacitor down in there. So decision is leave it out entirely right now. And we could even partially install it so one lead is connected, one is not, and I can wiggle it as a switch and switch it in and out. We can find out what's going on with it. I carry on with these other guys. Now, surely to goodness this is not going to be difficult to do. That's what I say. Well, let's get rid of those other three. I won't look at the schematic. Hey, that's a good idea. So, I thought I'd be able to replace those three capacitors without more intrigue, but no, the intrigue continues here. So you can see I've put in one replacement so far, no problem there. Not soldered in yet, but it's there. Here's the other guy here. Great. Not soldered in yet, but will be soon. I'm just about to do this guy. And Mr. Murphy is showing up. So if we look at this capacitor, one end of it, and I'm double checking everything here because maybe I've got it wrong. So one end of this capacitor connects to this binding post here. Here, come in a little closer for this because, yeah, I'm sorry that it's just a touch out of focus, but I can't help it. This camera's permanently out of focus, just a touch now. So, but I'm sure you can see the capacitor back here, and you may not be able to follow it, but the wire comes out and ties to this binding post here. This binding post is actually a ground terminal. This side, it's just all connected together and goes to the chassis right through this post. So this is a ground point. So this capacitor, one side goes to the chassis. The other side goes to this base decrement increment switch here. Now the way this switch works is the switch is mounted directly onto the chassis back here. And what you're actually doing when you turn the switch and move this slider is you're applying a ground in any one of three different places. This position, this last position, actually goes nowhere. This terminal's not used. So this way you apply a ground on this wire. This wire goes to this ground terminal. You're applying a ground to the ground. When you set it in the middle, you are now applying a ground through the switch to this end of this capacitor, the other end of which is grounded. Does that make any sense to anybody? It doesn't make a hill of beans worth of sense to me. It really looks like this is miswired. And once again, I'm in this terrible headspace where it looks like it's wrong, but it seems to work really well at the same time. That's a bad place to be. That's where I am. So let's verify all this nonsense here and see if it's really true. If everything I say is true, so maybe something's not true. Maybe we can figure that out. Where is the truth? It's just a little precarious like that. Okay. first of all, one lead to the chassis. A nice spot here to stick this. Right in there. One lead to the chassis. Let's prove it. There's another lead to the chassis, and you can't see a thing because of the way the light is here. There we go. Here we go again. Double checking my chassis connection. There you are, 0. Okay, so this terminal down here I was claiming is bolted to the chassis and produces a, let's see, you know what? I know what I was doing. I know what I was doing. I had this grounding switch up here switched to this wire. See? I was totally wrong. Now we see a ground there. Okay, that explains it. Just confusion. It's just confusion on my part. Not so much confusion, but misinterpretation of how the circuit works. Okay, so with that in mind now, so that means this position, no capacitors involved in this arrangement. This position, we're going through this capacitor. This last position, it's actually a wire going to this terminal. So you can actually see now quite clearly. There's a capacitor going to this terminal and a wire going to this terminal. And you're selecting between them. Wire, capacitor, nothing. So solid ground, capacitor ground, open. And this is affecting the bass response of the receiver. Of the amplifier, really, I should say. Okay, so, you know, just me. It's just, I'll get on with it now. Oh, the pain of it. Okay, time to solder them in. And we're going to start with this top one here. After I knock everything over here on my bench. Yikes. Runaway solder. That looks like a bad situation there. Look at that. Huh. I'm breaking one of my rules here. I'm holding the soldering iron in one hand while working with the other. It's not a good idea. Wow, that came out just ugly as can be. There we are. I've never made a claim that I'm good at soldering. I really don't want to make any claims here that I'm good at any of this. It is what it is. There we go. Okay, that guy's done. Do this guy next here. Big terminal. It's drinking in the solder somewhere. That's got to be good. The other end down here. here. And burn it into that other wire. There's a whole pile down in here. Look great. I think that's okay. Now, did I do every connection here? Probably not. Let's see. Done. Done. No, that's not good. That's no good. Is it? Yeah, it wraps way around in there. Toss a little more solder on that. Good. Good. Good and good. The next step with this guy is to operate it and attempt to determine if solder that. Just to double check it. If the harmonic distortion is good, that would be, certainly under 5%, maybe in the range of 2 or 3% total harmonic distortion, something like that. I'm not sure how I'm going to measure that with any, quantitatively. I don't know. Double check again. I did so many parts here. Good. I think we're ready to give it a try. Yeah, you can see I put this back in, even though I had reasoned that it's in the wrong spot. I have discounted my reasoning. I'm ignoring my reasoning, but I have reasoning behind that. I have reasoned that that's simply because I was misinterpreting the terminal down here. I made lots of misinterpretations in the schematic, all of them leading to bad conclusions, including that capacitor being a problem. I mean, after all, the set works. The set works. Okay, so now we're going to start this guy up as soon as I just unload my bench a little bit here. Make sure I can put the old voltmeter there. Speakers plugged in. Got signal generator connected to an antenna. What we're going to want to do, though, is we're going to want to pump an audio signal into this radio, into the phono input. Eventually, let's start by just playing the radio. Why not? I don't know why not. I just thought about it there and could think of no reason not to operate this radio, especially since I'm doing it on dim bulbs. Volume is down, tone is who knows where. This switch we will put into the open position. So we're not engaging this capacitor back here, and we're not engaging the wire. Okie doke. Let's hit the switch. switch has been hit. And dim bulbs are dim. They're dim. You know what, actually in my shop I don't have a dim bulb system, I've got a gym bulb system. Hey, what's up? Volume is down. Tone control. I'm having trouble with this tone control being dirty. Tone control is toning. Okay, who's doing that? Here's our chance to find it. It's persistent. Let's go and find it. A lot of noise. Switch it to phono. Phono makes no difference. Switch this switch. Just makes a tone difference. Volume. Volume makes no difference. Should make a no difference. Loose tube. Loose tube. Where's it going? Don't go away just yet. Don't go away. It's going away. That's interesting. Now I've still got it on restricted power, so it's heating up at a slower rate than it might have otherwise. And that crackling was quite distinct previously during the startup, but didn't last very long. The storm appears to have passed. Maybe we can bring it back here. You know what, there's a metal piece on there. It's maybe not the best poker. Let me get a nicer poker. So look, it's just gone completely silent now. Did I try the band switch? You know, I never got around to turning the band switch, so it's probably the band switch. Volume up. I don't hear a darn thing. Uh-oh, that's not so good. How come so quiet? Okay, let's try a little. Oh, yeah, that's right. I'm on phono. Maybe that's a good thing. Let's go back to radio here. I think all I got to do is get this button to pop out. I think. Quiet. What band are we on here? Turn down before you get. Okay, so we're on what I'm sure is the AM band. Oh. It's gotten awfully quiet. That's full volume. What did I do to it to knock the wind out of it? Just by putting new capacitors in? The only way that comes to my mind is, oh, of course I got this set open. So if this is open, this is not grounded, these are not functioning. I was going to say, maybe these are draining the signal. Don't like having my finger back here, but well, that makes no difference whatsoever. Well, I don't know what to think now. Is this a problem or not? Let's pump in an audio signal into the phono input here like we've done before. And see what we get. that's right, my speaker's broken. There we go. Okay, output is there. Turn this down, much lower. Output into the phono. Phono connections right here. Straight on. Boldly going where we're still on low supply voltage here too. Volume up a bit. Oh, volume's up all the way. Wow. Okay, push phono button. Wow. That is one sick sounding puppy there. That's full. Sound terribly distorted. Ooh. What's going on here? I turn this volume control, the volume drops off and then slowly leaks back up. Like an AVC. You can even hear on the upswing, you can hear the burst up and then the pullback. Huh. That tain't right. My first thought is get rid of these. The audio amplifier is this away. If I touch this, it should come out pretty loud out of that. You know what? This is after the volume control into the preamp. Well, what about, so that should be a lot louder, I think. Well, Jim, you've gone and done it now. Kind of a stupid mistake that I make. Oh, this is, you know, really out of the pan, into the fire. Okay, possibility is I'm just not giving it enough on here. This is probably meant for a 1 volt signal or so. Something along those lines. Where are we on that? Okay, so what I've done now, and I think I've realized why this is sounding distorted in a moment. But anyway, I hooked up this voltmeter to read the voltage level I'm feeding into the phono plug. So this is on the 3 volt scale. Just ignore those sudden jumps. I don't know, it's a little lead problem. 3 volt scale, 2 volts, 1 volt. So it's somewhere between 1 and 2 volts, falling off at the moment. Well, that's about correct, even though it's dropping. Full volume, nothing, almost nothing coming out. Let me check this phono push button here. Maybe it's the problem. No. The band switch, which appears to have 3 settings. Maybe one of them's phono. Somebody suggested that. You're probably right. That would be the one. AM. Not making any difference here. All indications are I mucked something up. I did 4 capacitors all at once. Oh yeah, the thing I really think it is, I forgot. I'm running this on low power. That's probably all this is, for crying out loud. Let's put it on full. In a moment. Let's see what we got now. Certainly better. Very heavy distortion, wouldn't you say? Let's try this tone switch thing. Now, I don't hear any difference, but then this is just a single tone coming in. So, and then here's the vernier tone control. So on a single tone, any tone control is just going to sound like a volume control. Doesn't sound particularly good to me. Certainly hear something in there. So what we want to do is examine now the output of this radio that we're listening to and look at it for distortion and stuff like that. So give me a minute here, I'm going to set something up. Give me just a second, video time. Okay, so now we're looking at, you're actually, as you can tell because my voice is showing up on here, this is reflecting what is being picked up by the microphones in my shop. And I have one stereo and one mono going right now, so there could be some funny stuff going on between these microphones. So bear that in mind. So what are we actually seeing? On the lower display is the spectrum analysis. If I shut up for a minute, you'll see there's a peak at 1 kilohertz. And you see there's another one at 2, another one at 3. So interesting questions here. How much of this is coming out of my audio generator and how much is due to the radio? Now what we want is one peak at 1,000 and nothing else. And we'd like that whole line on the bottom to be flat other than the peak. But it is a microphone picking up other sounds in the shop here. Let me change the frequency and we'll see what happens. We'll go down. Oh boy. Okay, so we're running around 200 hertz right now. And what do I see? I don't know, something at 400 and something at 600 there. Don't see anything around 200 really. Okay, let's go up till we see something. Oh. Okay, so I see something moving around 400. But in fact, we're running at 200. That's a 200 hertz tone you're hearing. Or you're really hearing 400 hertz because of the distortion. Let's go up. So now at this point, does my pointer show up on the screen there? I think it does. Hope it does. So, that's the primary signal. What is this guy doing here? Let's see. This is around 300 hertz on here. Boy, every time I talk, it just goes all crazy. 300 hertz. And we're dialed in at 300 hertz on the frequency generator. But here's a bigger peak at 600 on the display. Wow, I haven't done this very much. As usual, it's simple when you look at it in a book or think about it, but it's more complicated when you actually try to do these things. Especially in a an amateur shop like what I have. Let's go up in frequency a little further. So here we see the primary signal and the first harmonic about the same level. Now, this is kind of interesting. So the primary now is taken over. It's much higher than the first harmonic there. But I hear distortion in the sound. Sounds a little cleaner up here. I have to get her up to 1,000 here. Now let's fool around with some tone controls and stuff. We're at 1,000 hertz. You kind of think the tone controls might actually have no effect on 1,000 hertz. Let's see. Here's the bass switch. See nothing whatsoever, and here's the tone control. hear a huge change. Lots of higher frequency components. So there's a signal at 2K, or a harmonic at 3K, maybe even one popping up at 4. What I'm thinking about is, what am I going to do with this test? Okay, let's vary the input up and down, the input level. And we'll take it way up. And you can see more and more harmonics showing up, and the wave shape on the top. Go back down. And that wave shape never really cleans up on the top. Okay, you know what we got to do? We've got to. How am I going to do this? We got to look at this. We have to look at the nature of the signal coming right out of my signal generator, and I got to put it through a reasonable speaker here. I'm going to continue to do it with microphones. Okay, so what I'm going to do here is I'm going to take the signal out of my signal generator. I'm going to hook it straight to a speaker, which is kind of weird thing to do with that kind of. I mean, this may be a totally bogus test too, because of that impedance mismatching, something terrible. Okay, so I just attach it to the speaker. I don't hear anything now. Let's hear it. There she is. Okay, good. Now this is a nice speaker. I've grabbed the Nordmendy speaker here. This is a high quality speaker we're listening to. There it is there. It's got two drivers in it, a tweeter and a mid-range. Let's close my door. And we'll turn this up. Okay, I'll throw the display back on the screen here. There we see the 2K again. I'll turn the volume down. Turn the volume up. Well, it looks like I've got harmonics coming right out of my signal generator. Ah. Okay. More than one way to skin a cat, though. Shh! Don't let him hear that. So I have another signal generator that can generate audio tones. That's this one back here, a sweep generator. Yeah, that's kind of interesting too, because I can make audio tones sweep, I think. So what I want to do is listen to the output of this on the speaker. Put that down like that. We're going to give up on this one. Again, this is kind of a weird thing to do, hook up a signal generator output straight onto a speaker, but we can probably hear it. Let's see. Let's see. Now this is a little bit tricky for me here. I've got all kinds of adjustments I've got to make up here. Okay, back to our crazy experiment here. So I've switched to a different frequency generator, a much better one, and it's going to produce an audio signal. I'm going to start really low, around, well, probably around 100, maybe 200. Maybe we'll start at 200 hertz. We'll start, and it's just driving the speaker in here. So the radio's not in the picture here yet. We're just verifying that me even doing this with a speaker and microphones makes some kind of sense. So let's get a bit of a tone going here. Okay, so this is a 200 hertz tone. You see it's dead on 200 on the display. Get a little more volume. So I'm looking at 400. There is something there, but it's not much. It could very well be due to the speaker, or who knows what other effects could be going on in here. So let's accept this signal. We're going to go up in frequency here a little bit first. Oh, that's interesting. You can even hear it rolls off there. Well, then it's back. And this is 50. It's there. Okay, got an idea what the signal's like. Let me take it off the speaker now. A big speaker. And we're just gonna connect it into the audio input on the radio. I'm sitting here quietly waiting. Okay, let me stick it on. Okay, I'll turn up the radio. Oh my gosh. Well, that tells the story, doesn't it? Now, perhaps I'm jamming in too high of a level into the... I kind of doubt it. The amplifier is virtually full blast here. That's 100%. And that's probably 70% of volume. And I see a terrible harmonic distortion there. Let's go up in frequency. What's that 300 thing doing there? Oh, that is the thing. So I'm feeding. I'm sorry, I'm talking all over the display. I'm feeding in 300, and I'm getting a bigger peak at 600. Let's go higher. Okay, we're feeding in 400. That's a little better. It's 200 I'm feeding in. I'm feeding in 200, but you know what? We're hearing 400. But when I did this straight into the speaker, it didn't look like this. So this is telling me the harmonic distortion level in this receiver is terrible. How terrible is it? You know what? It's kind of musical when you're listening to stuff being played through it. It's hard to pick up these harmonic distortions in your ear because it kind of adds. Certain harmonics are not unpleasant to hear. Other certain harmonics are terribly unpleasant to hear. So what's all this telling me? This is telling me if I get this radio completely done and it still doesn't sound very good, it could very well just be the audio circuits. And talking about that, I should really put just regular sound through this thing and listen to it. I could do that, just let the radio play for a bit. I'll hook up the antenna to it and we'll listen to it, see if we can kind of hear these things that I'm suspicious now are in there. Let's fool with some tone controls here. I'm going to turn this up a higher frequency and fool with the first the bass switch. I don't see anything, and now the treble or the tone. And again, on a single tone, it's going to sound like a volume control. Let's go higher. Okay, doesn't seem to affect the ratio of the harmonics at all. So let's go way low. Let's go low. When they go low, we go lower. That's a 200 hertz signal being fed into the radio. A 400 hertz harmonic tone coming out of the speaker. Okay, tone control. Assuming this tone control is just a treble cut. It's funny, like I hear the trebly, the higher pitch sounds disappearing, but I don't see it on the screen there. Maybe they're already below. Anyway, okay, and the switch. Tone switch has no effect. Can we go lower? Go even lower. This is a 50 hertz signal now. Turning it way up. Down. Ooh. I don't hear it at all. No surprise. 50 hertz. Yeah, it's just too low. Let's take it up to... Let's try... Ooh, too far, way too far. Take me just a second here to adjust this piece of equipment up to around 100. Doesn't want to reproduce 100 really. This will be 200. So 200 makes 400. You know, this radio is headed to a cabinet with a transmission line speaker arrangement in it. It's really looking for high performance from the amplifier in the low frequencies. Otherwise, there's nothing. If there's nothing there, there is nothing there. It doesn't matter if you have this transmission line arrangement. So if we want this guy to really roar out the bass, which I think is what it's designed to do, then something's got to be done. I'm not sure what. Just working the volume control here. Nothing. Okay. Let's listen to the radio. Should I feed in? You know, I'm just going to tune in something here. Better listen to the radio itself. And we'll flip back to the picture here. Okay, I'm going to take off all these things here. Volume down. Okay, so this is the... This can be... This can be the loop antenna. Just okay, there's the loop antenna lead. There it is. Loop antenna engaged. Loop antenna disengaged. Wait a second. failing to plan and planning to fail here. If I don't change a few things. There we go. Let's try this now. I had the phono button pushed the whole time I was doing that, of course. That was my intention, but I wonder if what would have happened had I changed it. Okay, so we're on the loop antenna. That's interesting too. I had this set to the unknown spot. It's on AM now. Hello. Hello, radio. Oh. Hello. Come in, radio. Come in. What have I done here? Let's make sure this is on the open. And make it a bit of... What am I doing? What am I doing wrong? I ask myself that question a lot. Hey, this radio's gone totally dead. What's happened? Phono plugged in. Phono pushed in. Hey, give yourself a cigar if you got that. Now I got one of these buttons pushed in. Let's pop it out. All buttons out. I was going to say, why is this getting hot here? It's getting hot from this resistor. Hello, radio. Where have you gone? Oh, this thing was sounding great before. Wow, I really messed it up somehow. Oh boy. So some of that distortion is with this volume control right up. But that's it for the volume. Okay, great. So I've driven this guy into a hole here, I think. It's suspicious this switch has no apparent effect. Now it's assumably affecting the bass. And not going to hear it with the speaker sitting on top of my bench here. Maybe I didn't have it tuned right. Let me pick a different station here. Okay, I'm going to leave it there. I got to go work on a television set from here. Terrible distortion. It's gone from sounding pretty good to sounding really bad. Great improvement, Jim. Okay, well, we'll sort it out. Sometimes when you enable part of one of these guys to work well. It simply reveals the problems existing in other parts of the radio. I'll go with that for the day. Thanks for watching, and see you in the next video.